Now, then let's get to the actual coding. The game implementation. The first feature we want to implement is the game call buy-in process. The basic business rule here is that one native token can buy 100 game coin. Before we implement this feature, let's do a simple walkthrough of the current code base. You can start the app backend by run start server, and then start the front end by start client. And then let's create a new tab for other stuff. Let's wait for the first load of the app. I may need some cleanup here. Okay, the game requires us to log in with our apt wallet. Thus, it can charge us from our apt wallet. Let's log in first, and this is the game. Because my game coin balance is 0, I can't start a new game. The first feature we will be implement here is game call buy-in process. First, we need to install our two dependencies here. Let's run yarn add ArcBlock DID auth and ArcBlock DID react. Okay, the dependencies are there. Then we will do to add code to the code base. We need first do a simple walkthrough of the code base. The game contains two critical parts. One is the front end part, which is bootstrapped with create React app. This is a simple React application, as you can see from this file. And the backend part, it's a simple Express app, as you can see from here. And it's using MongoDB to store data. Okay, and the current login logic is here. It's in the API routes auth folder. And it's using the DID auth library already. The routes is loaded here. For the game call buy-in feature, first we need to implement the backend handler. Since this process requires connecting the apt wallet, let's create a new file called swap.js, and let's put the backend code in that file. This file is importing the swap storage part from the libs auth file, and it's exporting an object that can be consumed by the swap handlers. Swap handlers is defined here, swap handlers. And from here, we can tell that this handler wants the wallet to do a atomic swap, and the basic parameters are here. We are offering game coin. The default game coin amount is 100 game coin, and the exchange rate is 100, so that for the user, he need to provide one native token to get those game coins. And then we tell the wallet to set up swap. And after having the routes ready, let's import the routes here. And let's use swap. Okay. And for this, this is the backend part. And for the front-end part, we need to have a button on the index page. First, we need to add the buy coins button. And when user click on the buy coin button, we will be pop up a QR code dialog, and let's add a flag for that state. The swap open is a state that indicates whether the QR code dialog is open or not. When the user clicks the button, it's open. But before it's open, it's creating a new swap order that can be used to trace the whole process. And once we have the swap open set, we can open our typical library, typical DID auth dialog. The auth is using the most important parameter here is the action, which is set to swap, and it must be the same as this one. And then there are unswap close or unswap success. And this is also an important parameter here. It's the swap trace ID. And for the messages, after you can tell where are they displayed when we test the feature. Okay, let's go back to the test. When we click buy coins, we are prompted to do atomic swap. The swap said we will receive 100 play, which is 100 game coin, and we will send 1 TB, which is 1 native token. Let's select to confirm. Okay, the swap should be complete within 10 seconds or so. Then our game coins should be there. Now we can start a new game. But the start new game will not charge us now. The charging part is what we will be implementing next. Okay, it's working. Next, let's implement the authorization part. For the payment part of the game, if we are just using the transfer, each time there are two ways to do this. The most simple one is when the user click new game, we pop up a dialog that asks user to transfer two game coin to the game. Then we will give him a new game. But this is not the best user experience. With ArcBlock blockchain framework, we can achieve better user experience with something else. Maybe you are very familiar to some e-commerce websites that you add a credit card. Then when you buy something, you are automatically charged from that credit card. And with our blockchain framework, we can allow user to authorize the game to charge when the user starts new game. And the authorization is sent by the user and it's saved on the blockchain. And so it's auditable and it's public verifiable. And to implement that, first we need to add two more dependencies. One is the tx util, the other is did util. Let's wait for the dependency to be ready. Similar to the swap part, first we need to create a new auth root here. Let's name it as authorize.js. And let's put the content here. Then let's have a simple, quick walkthrough of the code. This code, we are using verified TX and to delegate address from the util labs. And we are also exporting object that can be consumed by our did auth library. For the claim part, we are asking the user or the apt wallet to send a transaction. The transaction is a delegate transaction. The delegate transaction is delegated to the game account. The wallet is the game account, as you can see from here. The wallet, it's generated from the environment app_sk. And the ops, the allowed ops on this delegation or authorization is that the game account can do transfer when the transfer meets the following rules. The first rule is the transfer value should be only 2, should be equal to, and the transferred assets should be empty. Thus that the game account cannot move any assets from the user. And the transfer to should be only point to the game account. And when the apt wallet has sent the transaction in this callback, we will send the transaction with Forge SDK. And this is the backend part. We also need to load this route here. And then let's implement the front-end part. For the front-end, we also need a button to allow user to send the authorization. And when user clicks the button, there is also a flag to set the auth pop-up QR code be open. And then when the pop-up, when the auth pop-up is open, we should render that pop-up. And the action parameter points to the authorize. I think that's it. And let's try the authorization part. Let's scan the QR code and select to confirm. The delegate details are not fully rendered on the apt wallet. Okay. For the delegation, we can see it from here. And the delegation is from the user account to the application account, and the delegation state is here. We can see that the rules are here. Each time it can transfer 2 tokens, cannot transfer assets, and can only transfer to itself. Okay. And the authorization part is done. Then let's do the payment part. For the payment part, we need to also add a backend API for starting a new game. in the API, we should charge user for 2 game coins. And on the front end, we should hack the game start stage. In that callback, we can call backend API to start the game and disable the start new game button and show a loading indicator when calling the API. And we should refresh the game coin balance when the user is charged. Okay, now let's move on to implement the actual payment part. First, we need to add a route. It's not an auth route here. Let's name it as game.js. And it provides a simple API that's used to start the game. We will check the user from the current request. And the user is decoded. As you can see, it's decoded from here. We are using bearer tokens for authentication. And then when the user exists, we just do a simple transfer. The delegator is the current user. Token amount is 2 and memo is start new game. And then we will wait for the transaction to be confirmed. And then we will return the transaction hash to the front end. And then after the route is ready, we should load it here. And on the front end, the proper way to hijack the onGame start is we add a onGame start here as a property for the game component. And the actual onGame start, let's just get the preparation code. We are calling the API defined here. And if that succeeds, we will refresh the session, which includes the current game coin balance. And we call the callback. Otherwise, we call the callback with error. And if you look closer at the game component, we can see that we have a game start here. If the parent provided a game start callback, then it will set itself to state loading, and then it will call the callback. And if we have error, it will render the error. Otherwise, it will init a new game, which the new game is not empty, so that it can be played. So now let's try the charging part. Since we have done the authorization and we are calling the new game. Okay. The game coin balance is updated. Let's try again. Okay. Let's try again. Seems works. Cool. And when we come here to the block explorer, we can see that there are 3 charging transactions. And the memo is here. Okay, the charging part is done.